first of all, I would like to congratulate you with the anniversary of 80-year liberation of Belgrade. So now I can move back to my slides. So today I'm going to talk about DNA genealogy of Serbs and the ancient history. Now I'm going to make 3 points. One is to show the structure of nowadays Serbs with Y-chromosomal and mitochondrial DNA features. Second, I would like to show a tragic history of Serbs, or I should say ancestors of the Serbs, which happened in the middle of 3rd millennium AD. I mean, actually BC, a 3rd millennium BC. And to talk about historical implications of what has happened, a long time ago. So this is a haplotype tree of Serbia and neighboring countries, which I would call former Yugoslavia. So now we see a very interesting tree which shows different haplogroups. In fact, it shows haplotype. Let me remind you a difference between a haplogroup and a haplotype. So I will compare with a passport. Passport has a cover and it has a number. So the cover of a passport is a haplogroup, which means it's common for very many people. It's not specific. However, it shows a so-called tribe of people. So in the audience, I believe maybe most of the people have the same passport. It means the same cover, the same color. And it doesn't say as much except they belong to one community. But now to be more specific, you have to go to a number in the passport, which is analog of haplotype. And the number is not unique as well, talking about the world, because the same number could be somewhere in Belgium or France or New Zealand. However, a combination of a cover and the number makes it unique. The same thing about haplogroup and haplotype. Haplogroup is a group characteristic, and haplotype is a specific individual characteristic. So now we can see, we plot here haplotypes of many people. You see one tight branch on the left, which is I2A Y3120. So why I go for that Y3120? Why I wouldn't just say I2A and that's it? Because there are two major kinds of I2A. One major kind, which is Y3120, is in former Yugoslavia mainly, which is Serbia, Croatia, and Bosnia and other countries. So now it is easy to call Southern Slavs or Danube Slavs, which doesn't go into Central and Western Europe. It concentrates mainly on in southeastern Europe. So now you see it's a very tight branch, which shows that it is young. When branches are scattered, they're bushy, they're ancient, they're old. However, as you see, I2A Y3120 is tight. In fact, it arose only 2,200 years ago, basically at the end of the old era, close to the beginning of a new era. And this is a kind of unusual situation, and I will explain why. Number, if you talk about Serbs specifically, you see the last line on the right, which say I2A M2023. It is only 2 of them. So you see 19 people. That's the highest amount among the Serbs. They belong to I2A Y3120. Now, and I2A M223, it's only 2 individuals because it's a Western group. M223 is mainly observed in in Central Europe and Western Europe, not in Serbia too much. Now we see, if we go from the bottom, R1A, there is M458, 6 people, and Z2809 people, which is second group in together, second group in Serbia. M458 is Western Slavs, and Z280 Eastern Slav. So you see it both represented in Serbia. Now, if to go up, we see R1B, P312, 8 people, and R1B Z2103, only 2 people. So I'll explain later what does it mean, but you see they represented in Serbia, but not too many of them. Now, E1B is relatively high number, 9 people in that selection, as much as J2B, the first line, also 9 people. I1, 5, and G2A, 3. So now you see it's a rough, of course, because selection is not large. However, it reflects properly the sort of stratification of different haplogroups in Serbia. My main point here that the highest amount of the last line here, which is Y3120. All right, so you see that percentage-wise. So that Y3120 is a third of all male Serbs. Basically, if you take a selection of 1,000 people, it will stay. About a third of all the Serbs is why they belong to Y3120. R1A 18%, mainly Eastern Slavs, or descendants of Eastern Slavs, 12%, M458, Western Slav, 5%. E1B 15%, R1B 6%, J2A 3%, and also there is a many minor, of course, quantitatively does not mean they are minor in significance. That's only 6% of the Serbs. They spread among a big number of different haplogroups. I1, J1, J2, N, Q, T, and L. Now, if we talk about time to the most recent common ancestor, there are some principle of calculations. I'm talking about now the left branch of the tree, which was shown before, which is Y3120. It has an ancestral or base haplotype. So what does it mean? It means that the person, which was a long time ago, in fact, 2,200 years ago, it contains his number of his passport, so to speak. I was just talking about it before. A sort of unique characteristic, which we can, we can recover it based on a multitude of nowadays Serbs, and it shows a number of those, figures here, number of digits here, which is useful because when you want to calculate when that common ancestor lived. All right, so we took all 67 haplotypes on the branch on the left, which is Y3120, and all of them have 495 mutations from that ancestor haplotype. If you take any other ancestor haplotype mistakenly, always it would be much higher than 495 mutations. So it is a minimized number. That's kind of a definition of an ancestor haplotype when it is the smallest number of mutations to everyone in the selection. So their common ancestor lived 495 mutations, divided by 67 haplotypes, and divided by 0.09, which is the mutation rate constant for 37 marker haplotypes. And you see it would be 82 generations with a correction for back mutations or reverse mutation would give us 90 generations. I would call it here conditional generation. Let me explain in a few seconds what does it mean, which is 2,250 years ago. Now, conditional generation is 25 years. Now, why 25 years? I'm sure everyone knows that it cannot be exact time for a generation because it depends on many factors. It depends on environment, on a diet, on religious principles, and so forth. So it is impossible to say exactly what is a generation. However, based on a number of things, one of them, the United Nations recommends 25 years for a generation when they calculate economics and other factors. Now we pick 25 years. It is not a real generation. It's a mathematical number using which we calculate 0.09 as a mutation rate constant for those kinds of haplotypes. If someone would like to say, no, I would like to pick 32 years per generation, no problem. Well, just he or she has to recalculate the mutation rate constant because these two numbers, like 82 in this case and 0.09 or 25 years, they connected to each other. That's why the final number, which is 2,250 years, would be the same, whichever number of years you take for generation. 25, 20, 30, or 50 years per generation does not make any difference because you have to recalculate, I repeat, that mutation rate constant. But anyway, the point is that the common ancestor of all bearers of Y3120, it says SNP, single nucleotide polymorphism, which I call briefly SNP. So with this SNP, whatever number of people you get, it would be the same number 2025, 250 years ago lived the common ancestor of all those people. So the question is, why so recent? Let me explain why recent means. If you compare different tribes, that tribe is a kind of genetic term for a community of people which are united in that they have a common ancestor. So if you see, we go for R1b in Central Europe, it would be 4,800 years. You go to R1a in Eastern Europe, it would be 4,900 years. For R1a in India, it would be 3,500 years. For R1a in the Middle East, which are descendants of those Mitanni Aryans, it would be 4,000 years. For Jews and Arabs, it would be 4,000 years. By the way, the Jews and Arabs, they have the common ancestor who lived 44,000 years ago. And in the DNA, there is no names. Of course, well, we know his name from the Bible or from the Torah or from the Quran. It's Abraham. However, of course, I have to say that it's not a scientific name because there is no name in the DNA. However, when Jewish, wise men, they calculated when Abraham lived, it turned out to be about 4,000 years ago. Now we go for haplogroup O in China. It would be 9,000 years the common ancestor lived. If we go to haplogroup Q in Native Americans, it would be 13,000 years ago. So you might ask, why so recent for the Serbs or former Yugoslavians, let's put that way, why is only roughly 2,200 years? Well, so it turned out that all autochthonous haplogroups in Central Europe have almost completely disappeared between 4,800 and 4,000 years ago, when it just was time when R1b bearers as bell beakers were populating Central and Western Europe. Ancestors of the Serbs were among those people who lived in Europe for a very long time. In fact, haplogroup I arose 43,000 years ago. However, after R1b bearers as bell beakers as an archaeological culture, they populated Central and Western Europe, people disappeared from those, including people who had haplogroup A, and now there is a gap in all SNP classifications between 43,000 years and now in about 2,200 years, there is disappeared and there is no even those SNPs in the classification. There is a huge gap for both I1 and I2 subclades. So not only I1 and I2, I'll show you virtually every haplogroup in Europe disappeared. Only R1b left. And now, because only R1b left, now about 60% of all European males belong to R1b group. Everybody else, all other haplogroups, if they're descendants of those people, a minimal amount who survived in Europe, or they will come back to Europe in rather recent times. So I repeat that I1A, Y3120, has suffered a survival bottleneck until 2200 years ago. Haplogroup E, V13, remember the third on number bears in Serbia, they also disappeared a bit later because the V13 arose 8,100 years ago. However, they recovered, the survivors only roughly 3,500 years ago. Again, there is a gap between 8,100 and 3,500 years ago. In other words, autochthonous males in Europe almost ceased to exist in the third millennium BC, including ancestors of present-day Serbs. Now, if you go to R1A haplogroup, which is the second one in amount, in quantity in Serbia, it is observed in 18% of Serbian males, of which 15% belong to East Slavic, R1A-Z 280, and only 3% to West Slavic, R1A-M 458. Now it's calculated from a much larger amount of haplogroup bearers. A common ancestor of R1A bearers in Serbia lived 4,300 years ago, plus minus 600, which is much earlier than the bottleneck time of 2,200 years before present in the Serbian Y3120. And you can ask, why such a discrepancy? Why 3120 were destroyed, or I would say went through hard times in Europe through a genocide? Why R1A didn't go through the genocide? Why they lived 4,300 years ago? The answer is simple. R1A, that time they lived in a Russian plain, in the middle of nowadays European part of Russia. They were descendant of a number of archaeological culture, and R1A formed 5,000 years ago. And in Fatyanovo culture, they lived from about 4,900 years ago. So basically, R1A, they didn't went through genocide in Europe, and they traveled, they migrated to nowadays, Serbia, and that's why they lived 4,300 years ago, 4,900 years ago in Russia, and 4,300 years ago, a bit later, naturally, it took some time for migration in Serbia. That's why, and I'm going to repeat it again, that's why when Serbs, ancestors of today's Serbs, they went through the bottleneck and start to multiply about 2,200 years ago, they already lived in a large number of R1A bearers which spoke Slavic language. And so that's why ancestors of nowadays Serbs speak Slavic language from R1A bearers. That's how Serbs became Slavs. And the same situation happened actually in all Eastern Europe, from East Germany. And in fact, in East Germany, there are plenty of R1A. It was a former Slavic territory. It was Germanized after all. And as you know, there is if you drive through East Germany, you see very many villages which bear Slavic names. Trashov, Windov, basically with the end on Ov and Yev. And that's actually a story of how Slavic language went to Eastern Europe. It went, as far as we know now, it went from the Russian plain, and in fact, the famous Russian linguist Starostin, Sergei Starostin, sorry, he calculated that the Russian language, contemporary, nowadays Russian language, and an ancient Indian language, the basic vocabulary is equal to 54%. So I have to repeat, 54% of basic language, basic vocabulary, it means the most stable words in a lexicon is ancient Indians and nowadays Russian language, not only Russian. In fact, I'm sure it's Serbian as well, because now the same, more or less same basic language, and Polish and Slovak and well, everyone who speaks Slavic language, they basically about 50% from 48 to 54%, they're same as ancient Indians. And that's why that language, who formed ancient Indians, they left the Russian plain, went to the east, and other people went to the west, and that's how the Indo-European language spread from India to Europe. That's why it's called Indo-European. Now, historical implication. Now I have to repeat because it's a very important message, I believe. It seems that at the recovery time of I2A Y3120, bearers in southeastern Europe 2,200 years ago, they were in close contact with the R1A bearers at the same territory and borrowed the Slavic language. Since then, Serbs become Slavs. Now, intermediate conclusions. One, Serbs are a multi-tribal society with a tragic history. In fact, I have to repeat, virtually all nations, countries, regions in Europe, they went through the same tragic history, except only one, bearers of R1b. And that's why 60% of all males in Europe, they belong to R1b haplogroup. Second, in the 3rd millennium BC, ancestors of the Serbs were largely decimated, and descendants of the survivors have recovered in I2A Y3120 haplogroups only 2,200 years ago. And third, thanks to those close interactions with R1b bearers who spoke Slavic languages, the survived Serbs become Slavic. Now, if we talk about haplogroup I, which is an ancestor to I2, ancestor to I2A, and ancestor to Y3120. There are many fantasy maps on the net, which place haplogroup I ancestor to Africa, where they suppose they migrated straight to the Balkans. However, there is no such data. Either about Africa or the migrations to the Balkans, no data. Instead, there are many ancient haplogroup I samples excavated in France, Spain, Portugal, Italy, Belgium, Sweden, Serbia, Hungary, Austria, Czech, Germany, and they are dated from 29,000 years BC through 2,500 years BC. Now, ancient samples. Ancient, which means they're excavated, in this case, on the current Serbian territory. There are known 27 ancient DNA samples of haplogroup I2A, which were excavated at the Serbian territory. 12 of them were discovered in the Iron Gate Gorge on the river Danube, dated a long time ago, 10,000 years BC, 8,400 years, 8,100 years BC, again, close to 8,100, 7,100, 8,000 years BC, and through about 2,000 years BC. So you see that those 12 samples, they cover a long history of that region, which now called Serbia. Most of them were of the lineage M2 to 3, which is now practically absent in Serbia. They either didn't survive or they left for Central and Western Europe. So now there is a very minority of people in Serbia who carry lineage M223. Most of them, as I said, Y3120. Now, company iFool, which I mentioned company iFool, YFool. It is the most known company which has a huge database, and they collect samples of people all over the world with a deep subclades. That means not only like in this case I or I2 or I2A, but many, many levels down. And they have that huge database, and they list 108 samples of Serbs with deep subclades, so that means many level of haplogroup I2A. And only five of them, imagine five only from 108, belong to Y3120, which passed the bottleneck only 2,200 years ago. The most of Serbs with, that's a bottleneck. However, the most of Serbs with Y3120 descend from a SNPs which arose only 1,800 years ago, which means, let me explain it. So the bottleneck was passed 2,200 years ago, but still majority of Serbs, they descend from a common ancestor who lived only 1,800 years ago. Because probably these 400 years between 2,200 and 1,800 were a hard time for Serbs to survive, for future Serbs. So this was again a consequences of genocide in Europe, which lasted from 4,500 through 3,500 years before present, and left a deep gap in Serbian history. All right, so now let's switch to E1b haplogroup in Serbia, which is pretty much represented in Serbian males. Company will list 26 samples of Serbs with deep subclades of haplogroup E1b. Remember, it was 108 samples with I and only 26 samples with the deep subclades of haplogroup E1b. Ancient A1b are not found as yet in Serbia. We know, however, that E1b bearers in Europe have passed a bottleneck 3,450 years before present, in the middle of the second millennium BC. So the same, destiny of E1b bearers, they also went through genocide. That was also a consequence of genocide in Europe described above. Now, if we switch to R1b in Serbia, there are not really many R1b. It's interesting because, as I said, 60% in Central, in East, in Western Europe are bearers of R1b, but not in Serbia. A company-wide full list 42 samples of Serbia's deep subclades of haplogroup R1b, plus 9 Asian samples of R1b. However, that's an interesting feature because those R1b in Europe are not those who live in Western and Central Europe. So Serbians are different R1b. All Asian samples belong to archaic sample subclade L754 V2219, which arose about 17,000 years ago. Very ancient one. But most of them belong to subclade V88. And dated, the subclade bearers lived in Serbia between 11,000 years ago and 8,000 years ago. And then they left Europe around 7,000 years ago for Central Africa. And now millions of their descendants live in Cameroon and Chad. This is indeed its very particular feature. So imagine a big tribe of V88 bearers that lived in Europe and on a future Serbia particularly, but on some reason they decided to leave Europe and went to Africa. And now it was a surprise to find that in Cameroon and Chad live millions and millions of R1b bearers with V88 subclade, which now it's hard to find in Europe at all. So probably they decided, well, we don't want to live in Europe, let's find a freedom in Africa. Now, 21% of Serbs, again, they belong to a different SNP, Z2103, which is almost absent in Europe. And this is SNP of Yamnaya archaeological culture. The main sites which archaeologists find of Yamnaya culture, they're on Volga River. So, and there is a belief actually still that believe that those Yamnaya people, they left to Europe by horses, killed everyone, and brought in the European language in Europe, so-called Kurgan theory. It turned out it's not true. Because in Yamna, indeed, almost everyone has, they found 12 people already in Yamna, ancient bones, and almost all of them had Z2103. But there is no Z21 in Europe except Eastern Europe. So it turned out that Z2103 bearers went not to Europe, they went to Caucasus and then to Mesopotamia, and now a lot of people, for example, a quarter of all Armenian males, they have Z2103. About 20% of Turkish, in Turkey, they bear Z2103. Many Kurds, many, Assyrians, they carry Z2103. But we go to Europe, in France, just several people. In British, in England and Britain, in fact, there is in fact only 9 people who carry Z2103 found in Europe. So apparently, in Eastern Europe, some of them left for Eastern Europe and stayed there. So you see, 21, which is 50% of all samples of R1b among Serbs, they carry Z2103. And Yamnaya culture, is dated by archaeologists are 23 to 4,600 years ago. And common ancestor they live about 4,000 years ago. Same in Serbia. So it means it was a frontier, how Z2103 went to Europe and stopped on that frontier, didn't go further. So again, I have to repeat here, they are not European Z2103. They came from the East, not from Europe. Now, if we talk about G2A haplogroup in Serbia, not many of them. Company Y-Full lists only 3 samples of Serbs with deep subclades of haplogroup G2A, plus 1 ancient sample of G2A dated 65 years ago. We know, however, that G2A are the same company, same unfortunate people who went through genocide. In fact, they barely went through genocide. They passed a bottleneck, and a common ancestor of present-day G2A lived 3,500 years ago. So they were almost all killed 4,500 years ago, and now the common ancestor of nowadays people, they went through the bottleneck 1,000 years after it. When we combine G2A haplotypes from Serbia, Croatia, and Bosnia-Herzegovina, and all they listed in mtDNA database, we found their common ancestor lived only roughly 2,100 years ago. So they were killed, most of them, 4,500 years ago, and the common ancestor lived only 2,100 years ago. So almost, more than 2,500 years later. So you see the same again and again, the tragic story. Genocide killed most of people who lived in Europe. By the way, remember that Otzi, the Iceman, who was found in Austria, close to Italy border, who was killed close to 5,000 years ago. It also carried a G2A haplogroup. So he was one of those unfortunate people who are largely killed, and I guess I know who are those people who killed them. They apparently probably belong to R1b. That's what happened across Europe. Now, the above studies and their conclusions were employing Y-chromosomal DNA. They have resulted in describing ancient events based on haplotypes, SNPs, and haplogroups, as well as calculating times to the most recent common ancestors of present-day Serbs. It should be noted that mitochondrial DNA is much less informative in revealing history of human migrations and other ancient events. Let us consider some examples. Now, before we go to the next slide, I have to tell that indeed, from a point of migrations, mitochondrial DNA is not informative. However, it tells us something. Let us show what it does tell regarding Serbs and also Europe and Eurasia. So if you go to mitochondrial DNA of Serbs, there is a remarkable picture. You see haplogroup H, 41%, U5, close to 10%, J, close to 7%, U4, close to 7%. So you see H is 41%. So most of Serbian women, I should say, they descended from haplogroup H mitochondrial bearer in Europe. Why I say in Europe? Let's move further. Now let's see how unique is that high number of mitochondrial DNA of Serbs in Europe. Not unique at all. Serbia, 41%, Russia, 41%, France, 44%, Spain, 44%, England, 45%, and only Finland is 36%. It stays kind of one side. However, still on the same order of magnitude. That's a haplogroup H. You go to U5 haplogroup, Serbia 9.4, Russia 10.4, France 8.2, Spain 8.1, England 9.1, Finland close to 21%. Again, Finland is different. However, Finland is different in many aspects. First of all, Finland has the major haplogroup is N, NY, N1A1. So there is almost no haplogroup N in Europe. And also Finland, people in Finland talk in Finno-Ugric languages. And except Hungary, there is no Finno-Ugric languages in Europe. So you see, it's different also in mitochondrial DNA. Haplogroup J, more or less same picture, like order of magnitude, same level. Serbia 6.8%, Russia 7.8%, France 7.7%, Spain 6%, England a bit more, 11.5%, Finland 5.9%. You see, regarding J, Finland now came back to the family of European people. So, but again, it's definitely not a majority. If you talk about U4, basically similar picture. Serbia 6.8%, Russia 3.9%, France 2.5%, Spain 1.9%, England 2.2%, Finland 1.1%. Yes, in Serbia, U4 is the highest amount. However, if you take into account that error margin, say plus minus 1%, maybe even plus minus 2%, it would be in the same family. Now, ancient mitochondrial DNA of Serbs. Now we talk about those excavated, the bearers of haplogroup H and subgroups which were excavated on the Serbian territory. H13, close to 9,000 years. So they lived a long time ago. H, 6,500 years. H1B, 3,900 years. H3H, 3,900 years. H6A, 3,900 years. So you see, interesting is you see women lived through the genocide times. It is confirmed by the following data with U4 and U5. I'll talk about it a bit later. Males were killed, but women were not killed in Europe. So, and there are some evidences in that regard. Now talk about U4, again, ancient, 9,500 years, 8,400 years, 8,000 years, 6,800 years, 6,800 years, 3,900 years. So again, they lived, and we know that women lived through genocidal times. Finally, I believe U5, again, from almost 11,000 years, now a long time. And here you see U5A1, they lived 8,000 years and 3,900 years and 1,800 years and 1,800 years, and the same with, and similar with other subgroups of U5. And now we go to East Asian haplogroups. Remember I said that Serbian carry largely or exclusively European haplogroups, not Asian. Now if we go to Asian, you see, and we go to Y full list. Bearers of haplogroup A, so many. It takes 160 pages on Y full list. C, 165 pages. A page was a page, and it's a lot of numbers on each page. Now D, 32 pages. G, 55 pages. And so a number of pages indicates how many people have been tested for mitochondrial DNA with deep subclade. Now, where those carriers of mitochondrial DNA live? Now, talk about haplogroup A. Serbia, only one person was found. Russia, 151. All of them are from Siberia. France, 1. Spain, 5. England, 8. Finland, 0. So in Russia, as I put here, this mitochondrial DNA was found only in Siberia. Now, Asian haplogroup C mitochondrial. Serbia, 0. Russia, 634. France, 0. Spain, 3. England, 6. Finland, 0. Again, all of them are in Siberia. Haplogroup D, Serbia 2, Russia 521, France 0, Spain 0, England 2, Finland 4. Same picture, all from Siberia. And G, the final one. Serbia 0, Russia 178, France 0, Spain 0, England 2, Finland 2. Again, all 178 are from Siberia. Now, that's why I said in the beginning that Serbian haplogroups are European ones. And it's not just a trivial statement. Who knew that maybe they moved from whatever, from Siberia, from from India or wherever? So no, they're in terms of Y-chromosomal and mitochondrial DNA, they are strictly European roots in Serbian. Now, historical implications. Now I'm coming to the end. French researchers have found that in the 3rd millennium BC, Y-chromosomal, that is male haplogroups in Europe dropped 17 times, while mitochondrial DNA stayed the same. It soon even increased in their amount. That was the time, I repeat, when R1b bearers, bell beakers have populated Central and Western Europe. Among those those Y haplogroups that have disappeared in Europe were, let's see, C1, E1b, F, G2A, H1, I1, I2, J2, Q, and R1a. So those were exterminated. I'm sorry for such a term, but what had happened when genocide happens. So all of them disappeared from Europe. And there is a gap, typically in the classification. Well, it sounds not really politically correct. And so that's ancestors of today's most of male population in Europe, in Western and Eastern, have not a very nice history. Of course, there is no fault of nowadays bearers of R1b in Europe, but that's historical fact. Well, I believe that's the last slide, so thank you very much.